I am rewriting the statement, the mathematical statement which I was writing in the previous session, because previous session was suddenly got disconnected. And so I'm going to write it once again, because most of the students probably have missed that one. So I'm going to rewrite this particular part once again. And this, this particular topic of the subject, of our subject, I mean, this discrete mathematics part is actually not a part where we can hurry. We have to be kind of your progress has to be kind of slow, because it actually requires much more critical thinking before you declare something. So my statement was, there exists y such that for all x, x plus y is equal to 0. Okay, and we have already discussed that this statement is a false statement. We want to study that it is what will be the negation of this statement. Okay, and if this statement is false, you are definitely sure that the negation of this statement will be a true statement. Now, what is the statement here? The property P here is x plus y is equal to 0. This is property P. And actually here I have written that there exists y for all x. Property P is satisfied. And our context of discussion is the set of integers. Integer set. So if I want to study the negation, then I must write that negation, there exists y for all x, x plus y is equal to 0. This implies, by the rule, there exists y becomes for all y. Then negation is carried forward, and we write it as for all x, x plus y is equal to 0. Then further we write for all y, this becomes there exists x, negation is further carried forward, and we write negation of this, and then we write for all y, there exists x such that x plus y not equal to 0, and definitely this statement is a true. This statement is a true statement, because this one is a false statement, and so this will be a true statement. So that's how we actually try to use the there exists and for all in writing the mathematical expressions, mathematical proofs. I am going to give you some more example over here. Suppose I'm choosing an example where I'm stating that all primes are odd. All primes are odd. I want to actually test this particular statement. Okay. And suppose I have asked you to test the validity of the following statement. Test the validity of the following statement, that all primes are odd. Now you see, from this particular example, you will get to see that why this studying of universal and existential quantifier and this mathematical logic is so important. Because we have studied analytical methods in mathematics, we have studied numerical methods in mathematics, but here we are actually learning another method which is called logical approach to mathematics. So a question may come to your mind that why can't we solve it analytically? Why can't we prove it analytically that all primes are odd? Prove or disprove? Why can't we do it numerically? Because it is not possible, because we do not know how many primes are there, and if I keep on increasing my numbers, then after a certain point of time, we are not sure about the number whether it is a prime or not, because there is no such universal rule. and it is still being studied in the mathematical community. There is a very good book on prime numbers, which is actually was written for a general public. The book's name is Prime Obsession by John Derbyshire. It's a very wonderful book. So if you have any fascination about the prime numbers, you can go through that book. Okay, it will tell you about the history of prime numbers and how the different mathematicians started studying it and failed, and what is the current progress, okay, in this particular domain, in this particular area. So the book's name is Prime Obsession. It was written by John Derbyshire. Now, if I want to test the validity of this particular statement that all primes are odd, how can we do with the help of mathematical logic? Now, here comes the actual application of the mathematical logic that we have so far learned. To logically deduct the truth, of or falsity of the statement, let us proceed as follows. Okay, I'm going to the next page. I can see 48 participants, but only 34 participants have so far written their roll numbers in the chat box. Others, please do, because this is how I take my attendance. Now, how can I do it? What is the process? First of all, let us write the statement Px, which says that the number x is a prime number. Okay. And let us write another statement which we call Ox, and I'm writing that the number x is odd. By the statement that all the primes are odd, which is to be studied, it actually implies that we are supposed to study that for all x, Px implies Qx. Carefully listen to me. It's very important. This part is very important. We want to check the validity of this particular statement. So mathematically, we have written that, okay, all the primes are odd. That means we want to check the validity of the statement that for all x, Px, that is, which means that x is prime, it implies that x is odd. That means when a number x is prime, then it is odd. Okay. Now, we cannot study them because we are not, our knowledge about the prime numbers is very poor. We don't know about many more prime numbers. So since we cannot directly check the validity of the argument, we try to take the help of the negation of this argument. Okay, so negation of this argument. Now, to check, we consider the negation of this argument. So this means we are going to test, what does this mean? That negation for all x, Px implies Qx. Okay. Now, by the property of the negation, this becomes, negation of for all x becomes, there exists x, and this negation is carried forward further, and it precedes the statement Px implies Qx. Px implies Qx. Now, you know that there exists, if you write this is equivalent to there exist, now negation of px implies qs is actually mean that px does not imply qx, or you can say that this can be written as there exists x such that px and not qx, not qx. This is also true because you know that if I consider two statements p and q, then you can very well check that the statement p implies q and p and not q, they will be having the same truth table. Their truth table are same. Their truth table are same. So sometimes sorry, p doesn't imply q, and p and not q, their truth table are same. So you can check it by yourself. So instead of, you can write this as px doesn't imply qx, and or you can write px and not qx, because x is prime but x is not odd. So what is actually saying? It is saying that there exists a number x such that x is prime and x is not odd. And immediately, if you think of, if you can think of, you know that such a number is actually there in front of us, and that number is actually 2. 2 is a kind of prime number, which is 2 is a kind of number which is prime, but it is not an odd number. So therefore, we have found a contradiction over here, that a number which is a prime number but not an odd number. We wanted to check the validity of the statement that all primes are odd. That particular statement is actually false. So from this particular argument, we have come to know that all the primes are odd is not true. So this statement is not a valid statement. This statement is not a valid statement. I hope that you have understood this particular part. Okay, let me show you another example. Okay, here is a quick exercise for you. You try to find it out by yourself. I'm not going to ask you to mathematically verify whether this kind of thing exists or not. I'm just asking you to check. Try to find out the negation of the argument. Negation of the argument. All prime numbers bigger than 2 are odd. Now, I'm not asking you to find such prime number. Remember, here I'm only telling you, I'm only asking you to write the negation of the argument as I have shown you in the previous 2 examples, by using the universal and existential quantifier, that how do actually we find the negation of a particular argument. You just try to find out the negation of this argument, just the way I have shown you in this particular board work. Let us discuss another example. Okay, let X denote a person. Let X denote a person. Okay. Now the property Px gives you the statement that X plays for sport team capital T, and property Hx, it means that X is healthy. X is healthy. Now the question is, what does this argument or mathematical statement actually means? What does this actually mean? And okay, let us try, let me finish the question. What does this mean? And what is the negation? What is the negation of the given statement? What is the negation of the given statement? Now you see that there exists X such that Px and not Hx. If I look at this and if I study what is given over here, you know that actually here the context is it is the set of players. We are actually talking about the player, the set of players, okay, or the set of sports persons. So here the context is not a number. Second is, as it is given, as the properties Px and Hx are defined, it means that this implies that there exists a person, such that there exists a person X such that X plays for sport team T and X is not healthy. There exists a person X such that X plays for sport team T and X is not healthy. So this actually means that the meaning of this particular statement which I have written actually means that not all the sport persons are healthy. What will be the negation of this particular statement? Let us try to find out. So negation is actually defined as, is denoted by this, as you already know. So when we write negation, there exists Px and not Hx. It implies, it's by implication, that it becomes for all X, and negation of Px and not Hx. Okay. Now try to recall the De Morgan's law. De Morgan law. De Morgan's law was what? What was De Morgan's law? It said that negation of P and Q, that will be equal to negation of P or negation of Q. Another statement is there, negation of P or Q, that implies negation of P and negation of Q. Now, by De Morgan's law, we can write it. This is actually similar to that one. So we can write it as negation of px or negation of hx. And you know that principle of double negation gives you this one. This is called principle of double negation. So negation of negation p is equal to the p. So that implies for all x, negation px or hx. Negation px or hx. So what do we get? Now, you know that if you try to find out, I'm writing over here, if you have two statements like P and Q, then negation of P or Q, the truth table of this is actually equivalent to P implies Q. So from here, I'm getting that this is actually equivalent to for all x, px implies hx. And that means what? That means all players playing in sport team T are actually healthy. So in this manner, in this way, we can get we can study the statements which we often encounter in our everyday life. In most of the cases, in practically in newspaper, you will find out statements which are very misleading. The person who is writing the statement in the newspaper, he meant something, but when we study that same statement, we actually mean we can mean something else. As I told you in my last class, that when I say that the boy saw the girl with a telescope, this particular statement is very vague statement, you know, because some people may think that the boy is using a telescope to see the girl, and some people may think that okay, the boy was seeing the girl who was having a telescope. Now the two meanings can be set from there. So in everyday life, when we talk with each other, and as I'm speaking with each other, we are actually not being very careful about what we speak. So we just speak, and therefore once you have this mathematic, but this, if you try to apply this kind of qualities, inherent qualities of us, by not thinking before speaking, to write mathematical arguments or computer algorithms, then there will be a disaster. And therefore these two techniques, these tools have been derived, where we can, before we proceed to write something, we remain very careful about what you are writing. Because when you are writing program, actually what you are actually transferring your thought, the thought of that your brain is working on, to an android or to a machine, to a robot. This is the mechanism of artificial intelligence, and this is the mechanism of machine learning and deep learning. Okay, you know very well, probably you know this, that deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. So I'm talking about the big domain. The robot Alexa, the robot, is actually being given all the inputs that you are having, you had in your brain. So when you are transforming this data, you cannot just haphazardly transform the data. You have to tell this robot that, yeah, if this is the scenario, then you think that this is true for all these, there exists such a kind of thing that this doesn't happen. So you have to be very careful about when you write these algorithms. And therefore this principle of mathematical logic or critical mathematical thinking is so important. Now I'm going to show you another example. Suppose I'm writing that for all x greater than 0 implies there exists y, x, y is equal to 1. And I'm asking you to justify the fact that whether it is true or false. Okay. Now, immediately you will ask me, that I can't say the validity of this particular statement until you give me the until you give me the context. What is the context you are talking about? Here, the context is not clear to us. So your statement is not a valid statement at all, and therefore we cannot verify its facts. These facts, we cannot verify its truth or falsity. Once I say that, okay, this quantifier, this context I'm talking about is the set of real numbers. Set of real numbers. This is my quantifier. If my answer is like this, you will immediately understand that, okay, then this actually the given statement is actually true. The given statement is actually true, because for all x, for all real numbers, x is positive implies that there exists a real number y, so that when we multiply x by y, then the result is 1. Okay, so y is actually becoming the inverse of x. Y is becoming the inverse of x. And you know that why this x greater than 0 is being taken, because we know that 0 doesn't have any inverse with respect to multiplication of real numbers. So the thing which has been written over here, if one tries to write it appropriately, then he must write it like this, that for appropriate notation for writing the statement would be, appropriate notation would be, for all x belonging to R, the set of real number, x greater than 0, there implies that there exists a real number R such that when we multiply x by y, it becomes 1. It means it is equivalent to the statement that for all real numbers x greater than 0, there exists a real number y such that xy is equal to 1, where xy means the product of x and y have been taken, product of x and y, and this gives us that every non-zero real numbers have their respective inverses with respect to the operation of multiplication. Of real numbers. Why have I shown this particular example to you? Because you see, just look at the volume of the words sentence that I have written over here. So look at the volume of the sentence that I have written over here. The sentence is so large. And when we write this particular, look at the size of this particular statement, which is written above. Look at the size of this and look at the volume of that. Now, this mathematical notations like existential quantifier or these universal quantifiers, when they are actually used, they try reduce our time of dealing with that. The time of dealing with the understanding of the mathematical knowledge that we are working on. If the mathematical knowledge is not, but if to do the proof of a particular theory, if we write this volume of sentences again and again, then it will kill time and will not be able to do much mathematics on that. Another thing, another note that I want to make at this point is that you will find in the books, in most of the mathematical books, the writers often they use the quantifiers, but they often actually avoid writing the context. Because, say for example, probably you have seen in the book. So my current note is that mathematicians often avoid writing context. Mathematicians often avoid writing context. So what does it mean? In books, you may find that they have written that x greater than or equal to 0 implies root x greater than or equal to 0. And you know that this particular statement is actually true. But if you encounter such statements in the book, you will definitely understand that probably the mathematician is talking about, and suppose you are studying the book on real analysis. Okay, so you will definitely understand that this particular statement which is written is talking about the number x, which is a real number. Okay, so whereas the actual statement could have been, for all x belonging to R, when x greater than or equal to 0 implies root x greater than or equal to 0. Now, this could have been the actual statement, and I will recommend you to stick to that. But some mathematicians try to avoid writing the context, and therefore they are not doing any, they are not making any mistakes by writing so. Why is it so? Because in these cases, they are going to the fact, they are moving with the fact that this is a kind of implicit quantification where the context is actually clear to us. This is a kind of implicit quantification where the context is actually clear to us. Now, so first of all, this context and these quantifiers have nothing to do with the context. You can use the context, you can use the quantifiers without mentioning the context at all. But if you have the implicit quantification, but if you do not have the implicit quantification, if this book is a general book of something else, which contains numbers, animals, people, books, everything in it, then you have to be very careful about the context. And before I conclude my today's session, there is another example which I'm going to show to you, that suppose we come across, suppose we come across the statement say x greater than 0 implies there exists y square equal to x, where x is a real number. So you know the context is clear. X is real number, so its context is clear. Real number or real, I must say, to be more specific, that x is a real variable. X is a real variable. Now, question is, which of the following statements, is it an abbreviation of? So 3 statements suppose are given. For example, I'm writing for all x greater than 0 implies there exists y such that y square equal to x. Then I'm writing b for all x greater than 0 implies there exists y square equal to x. Number C, I'm writing for all x greater than 0 and for all x there exists y square equal to x. Now, this type of questions you may encounter in the examination. In examination, they will give you a statement like that. Okay, as you will all be sitting for the online examination, so naturally a question is coming to your mind that what sort of problems we may encounter in this type of topics. Because if it were a physical classroom examination, then many questions can be set, and lot of things we were actually supposed to do over there. But since we will be sitting for the mathematical, since we'll be sitting for the online examination, what sort of questions they may ask in the examination? So this is an example of the question which they may ask in the examination. So they have given you a statement where it is written that x greater than 0 implies there exists y square equal to x. Context is clear, that is x is a real variable, so that is the context. This is the context, and they are asking you that which of the following statement is actually correct. Okay, now you see that definitely the answer will be which one? Can anyone say which of this particular statement will be correct? A, B, or C? Because I don't have much time. So if anybody is thinking anything, then he or she can write in the chat box. Yeah, this Antara Kumari, you have done it correctly. Others can think that can think on this, that this particular statement for all x greater than 0 implies there exists y such that y square equal to x will be the correct statement, and these two statements will be the wrong statements. Since no much time is left for today's session, I am going to stop my session of today's class at this point. I couldn't finish the topic, I couldn't start the topic of proof techniques in today's class because it took up my time. This discussion was actually very important and it was also very time taking. So tomorrow in my session, I'm going to discuss about the proof techniques, and with that, we'll be able to complete the section of this particular section of the syllabus. So tomorrow we are going to meet at our scheduled hour. Till then, bye, and I'm going to upload the note tomorrow.